everyone, I'm Malia Erica A. Javier, BSc 3G, and this is MECH 312 Dynamics of Rigid Bodies. So for rotational motion, I choose example number 2. So the pinion A of the host motor drives gear B, which is attached to the hosting drum. The load L is lifted from its rest position and acquires an upward velocity of 3 feet per second in a vertical rise of 3 feet with constant acceleration. So as the load passes this position, calculate for letter A the acceleration of point C on the cable with the drum, and for letter B, the angular velocity and angular acceleration of the pinion A. So for letter A, so to calculate the acceleration of point C, first we calculate the tangential acceleration. So we have b squared over 2s, or the position, is equals to our b, or the velocity is equals to 3 feet per second squared over 2, and yung s natin is yung 4 feet. So therefore, our tangential acceleration is equals to 1.125 feet per second squared. And for normal acceleration, we have v squared over r, and yung velocity natin is 3 squared. And so our radius is from 48 inch. So this 48 inch is the diameter. So we need the radius, so it will become 24 inches, and to become convert it to foot or feet, it will become 2. So our normal acceleration is equals to 4.5 feet per second square. So to get the acceleration of point C, we will use this formula. So acceleration at point C, square root of tangential acceleration squared plus normal acceleration squared. So we have, it is equals to our tangential acceleration 1.125 squared plus the normal acceleration 4.5 feet per second squared. So therefore, our acceleration at point C is equals to 4.64 feet per second squared. So for letter B, angular motion of point A is determined from angular motion of point B by the velocity and tangential acceleration of their common point of contact. So angular motion of point B is determined from the motion of point C that is attached from drum. So to calculate the angular velocity and angular acceleration of pinion A for letter B, first calculate the angular velocity at point B. So this is point B. So we have v over r is equals to, our velocity is 3 and the radius is 2. So we have angular velocity at point B is equals to 1.5 rad per second. And for angular acceleration at point B, we have tangential acceleration over r is equals to, so our tangential acceleration is 1.125 and our radius is 2. So we have angular acceleration at point B 0.562 rad per second squared. And using this, velocity 1 is equals to radius at point A multiplied by angular velocity A, and also it is equals to radius of point B multiplied by angular velocity of point B, and then for angular acceleration 1, we have RA, angular acceleration at point A. It is also equal to radius at point B and angular acceleration at point B. And then, to get the angular acceleration and the angular velocity, so using this, we will calculate the angular acceleration at point A. So we have RB over RA multiplied by angular velocity at point B. So we have, so yung radius at point B is, since 36 siya, divide 2, it will become 18 inch. And to convert it into feet, it will become 1.5 over, and then yung radius at point A naman is 12 inches. So, to convert it into feet, it will become 0.5, and our angular velocity at point B is 1.5 rad per second. So therefore, our angular velocity at point A is equals to 4.5 rad per second. So it is counterclockwise. And for angular acceleration at point A, so we have gamit naman to. So we have RB over RA, and angular acceleration at point B is equals to, again, our radius at point B is 1.5, and the radius at point A is 0.5, and then our angular velocity at point B is 0.562. So therefore, our angular acceleration at point A is equals to 1.688 rad per second squared and counterclockwise. So this is the answer for letter B.